This overview will discuss how the Recovery 2.0 system utilizes working fluid pipelines. The Recovery 2.0 system is an innovative approach to manage the treatment of residual waste materials, in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy by using thermal reduction. Thermal reduction is a high-temperature process that is used within the Recovery 2.0 processes to achieve resource recovery. One approach to thermal reduction, that exploits energy at intense heat levels, relies upon a system that is based on 4 main working fluid pipelines, and in addition, also uses a collection of ancillary working fluid networks. Within the Recovery 2.0 process, we have focused a great deal of effort on energy recovery in an effort to manage the energy continuum while attempting to maintain a balance or equilibrium with our environment. The 4 main working fluid pipelines that we wish to focus on in our overview are a mixed hydrocarbon pipeline, a water-steam pipeline, the CO2 pipeline, and a compressed air pipeline. Some of the ancillary working fluids, in either a liquid or gaseous state, may include hydrogen, oxygen, nitrogen-based fluids, a variety of refrigerants and oil circuits, and several acid cycle pipelines. As an overview, let's first look at the mixed hydrocarbon pipeline. This is the initial stage, at the point of conversion of various raw waste material feedstocks, at the exit of the thermal reduction reactor, that interacts and transports the mixed pyrolysis output of working fluids, further into the recovery process modules. This hot gas pipeline typically conveys a mix of dirty syngas, and a variety of condensable hydrocarbons in a hot gaseous vapor state, and includes CO2, water vapor, and a small amount of residual materials. The mixed hydrocarbon pipeline facilitates the contained movement of the mixed fractions into the various separation stages. The second working fluid overview looks at the water-steam pipeline. This system is designed to handle the conversion stages of wastewater, brines, and the water contained within organic and hydrocarbon waste materials. This circuit facilitates the extraction of kinetic, thermal, and chemical energy with the output of clean water. Within the Recovery 2.0 thermal reduction process, we generate plenty of waste heat at high temperatures, that may be used to convert water into steam for power generation. By utilizing the potential energy within the water pipeline reservoir network, you may use hydro storage as a robust, on-demand power source. In the third overview, we look at the CO2 pipeline. With the thermal reduction of the bulk of waste materials that we encounter, we largely end up with carbon-based elements. In the recovery process, at some point, we deal with carbon dioxide in a gas state. The versatile treatment of CO2 also facilitates or supports the transition to and from carbon, in a solid state. Carbon and CO2 are fundamental cornerstone materials that contain robust energetic properties, in the fields of thermal energy and kinetic energy transfer, and in electrical, chemical, and electrochemical reactions. In the fourth overview, we cover the span of the unique characteristics of the compressed air pipeline. Air is a resilient working fluid that facilitates the rapid regeneration that supports the transfer of energy. The compressed air pipeline taps into the properties of this amazing energy transfer media. In summary, we intend to discuss each of these working fluid pipelines, in greater detail, at some point in the future. Until then, please feel free to contact us at your convenience. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us today at www.waste.net.